So 6.1, remember this is only going to be part of it. We won't get through the whole thing. A lot of it is going to be a review from Algebra 1, but you may have still forgotten a lot of it, and that's okay. So remember, I am recording. You can still ask questions if you want. So a monomial, we're starting out with a monomial. That's just a number or a variable or numbers and variables smushed together. So like 7, 3x, 12x squared y to the 9th. Those are all examples of monomials. So just there's no addition or subtraction between them. And in Algebra 1, you learn some rules, and we've kind of used these. We don't really think of them as rules. They're just things that you kind of remember how to do. So the first one is the product rule. When product means to multiply. So if we're multiplying x's. So if we have x to the a power times x to the b power. So we're multiplying variables. We're multiplying x's. You don't multiply the exponents. Does anybody know what you do to the exponents? You combine them, you add them. So x to the a plus b. So if you are multiplying variables, you add the exponents. So an example, if I have x to the 5th power times x to the 3rd power, that is going to be x to the 8th power, because 5 plus 3 is 8.
Oh, okay, so it's a simple addition with the exponents.
Yep, you just add the exponents. Okay. Now next is the power rule. So raising an x to another power. So if I have x to the a raised to the b. So basically we have an exponent inside of an exponent. In this case, you multiply x to the a times b. So x to the 5th raised to the 3rd power. This would be x to the 15th, because 5 times 3 is 15. Now, if we have the quotient rule, that is, quotient comes from division. So if I have x to the a divided by x to the b, we subtract x to the a minus b. So if I do x to the 5th divided by x to the 3rd, that is x squared, because 5 minus 3 is 2. Then we have something called the negative exponent rule. So let's say that I have x to the negative a power. We don't leave negative exponents. That's Just not really, we just don't do that. You don't have an answer. You don't leave an answer where there's a negative in the exponent. So if we want to make it positive, we make a fraction, and that x goes to the bottom of the fraction, and that a becomes positive. So if you move it to the bottom of the fraction, it becomes positive. And you don't leave a blank on a fraction, so we just put a 1 there to kind of be a placeholder. Now, if it started out as a fraction and the negative was in the bottom, then to make it positive, you move it to the top. So it moves either way, the other way. You know, if it's on the top, it goes to the bottom. Bottom goes to top. And then that a becomes positive. So, for example, if I have x, actually, let's do 2x to the negative 5th. So I want to show you something. 2x to the negative 5th power. The only thing that moves is the x. That 2 does not move with it. The only time the 2 would move is if there were parentheses around the 2x, but there's not. So this is the same. The x to the 5th goes to the bottom, and the 2 stays up top. So you put the variable on the bottom, and its exponent becomes positive. And then the last one is anything with a 0 exponent is equal to 1. So if I have 320 x to the 9th, and all of that was raised to the 0 power, the answer is 1. Anything raised to the 0 power, except you don't do 0 to the 0 power. That's just weird and confusing. But anything else to the 0 power is 1. So let's do some examples and throw these all together. So number 1, 5x squared times negative 7x to the 6th. So when we are multiplying, if you have numbers out front, you just multiply those like normal. So what is 5 times negative 7? Negative 35. And then we do the, let's see, x squared times x to the 6th. And so we're multiplying variables. That's the product rule. This would be x to the 8th. Because the product rule is when you are multiplying. So if you want to go back and write multiply, power rule would be exponents, I guess. This would be division. So if we're multiplying, that's the product rule. So the answer is negative 35x to the 8th. So any numbers out front, you just do those like normal. Okay. All right, number 2. We have some things here in parentheses, and that's being squared. We apply the square to everything inside the parentheses. So we would do like negative 2 squared, a cubed squared, b squared. So I'm applying that squared to everything in the parentheses. So what is negative 2 squared? You can use your calculator. Make sure you put parentheses. Negative 2 squared is positive 4. And it is bathroom. Negative 2 squared is positive 4. Now here we have a cubed squared. This is the power rule. You multiply these exponents. So this would be a to the 6th. And then b, it's just b squared because there wasn't anything to multiply by. Number 3 is the quotient rule, which is division. Now these numbers, this 54 and the 3, you just divide those like normal. These rules are only for the exponents. So 54 divided by 3 is 18. Okay. And then we have the m's. So, hold on. We have m to the 6th and m squared. So m to the 6 is on the top, m squared is the bottom. If you look at your quotient rule, you subtract the exponents. So 6 minus 2 is 4. And then the n's, we have an n to the 4th and an n to the 1st. So that would be n cubed. So 18 m to the 4th n cubed. Number 4, this is a multiplication problem. So the numbers out front, you just multiply like normal. That would be 20. 2 times 10 is 20. And then the k's, whenever you multiply variables, you add the exponents. So 4, what is 4 plus negative 3? Yes, but what's 4 plus negative 7? Negative 3. Yes. I gave you the answer, so negative 3. 4, so k to the 4th times k to the negative 7th is k to the negative 3rd. But we don't leave negatives in the exponents. So we've got to take this k to the negative 3rd and move it to the bottom. So it becomes 20 over, and that 3 becomes positive. So when you move it to the bottom, it gets to become positive. All right. Number 5, we have 15 over 24. That does not divide into one whole number. So if you go to your calculator and you do alpha y equals, and you hit enter, and you type in 15 over 24, it simplifies it for you. It simplifies it to 5/8. And then we have x to the 10th over x to the 12th. So that would be x to the, it's the quotient rule, which means we subtract the exponents. 10 minus 12 is -2. And we don't leave an x or a negative in the exponent. So if we bring that to the bottom, that -2 becomes +2. So 5 over 8x squared. So anytime you have a negative exponent, you got to get rid of that. Now, another way you could look at this without having to think about it in subtraction is you could say, all right, there's 10 x's on top, x to the 10th. There's 10 on top, and there's 12 on bottom. That means that the bottom has 2 more. So all of them are going to cancel except for 2 in the bottom. And you could say, well, since there's 2 more in the bottom, I'm going to have x squared in the bottom. That's just another way to think about it. Okay. Number 6, this one's got a few things. Let's do the exponent part first. So we have to take that 4 and apply it to both the 2 and the c cubed. So first off, what is 2 to the 4th power? Use your calculator. 2 to the 4th power is 16. And then c cubed to the 4th power. That's the power rule, and we multiply the exponents. So c to the 12th. Then we still have times. And let's do the other one. -3 to the 3rd power. Make sure you put that -3 in parentheses. What?
-27.
It is -27. And then c cubed is just c cubed. Now when we multiply, let's do the 16 times -27. And you get -432. And then the c's, when we multiply variables, remember you add the exponents. So that would be c to the 15th. Any questions? We are going to be using these rules all throughout the units and parts of it. Parts of the unit, we won't. It's kind of just a big jumble. This unit is just a lot of different stuff. So let's see if we can get a few more things. We will get this next section filled, and then we'll stop there. And I know that many of you did this in Algebra 1, because I know that Algebra 1 is doing it right now. So I know they did this. So a polynomial is when I take monomials and I just add them and subtract them, like 2x plus 7x squared minus 3. Those are all polynomials. And something that's important is the degree. The highest exponent of a polynomial is called the degree. So you look at all the exponents, and whatever the biggest one is, we would say the degree is 4, whatever. Now, it's always important to write your answer in descending order. That means largest to smallest. So your exponents, you write largest to smallest. And we're going to name polynomials based on two things: their degree and the number of terms. So I'm going to give you what goes in these charts. So if the degree is 0, that means there's not an x at all. No x, no variable. It's just a number. We call that a constant. If the degree is 1, so your largest exponent is 1, we say that is linear. If the degree is 2, this is all what Unit 5 was about, we call it a quadratic. If the degree is 3, we call it cubic. Four is quartic. And 5 is quintic. Now after that, I'm sure they have names, but we won't see any of those. So every polynomial has two names. It has like a first name and a last name. First name is its degree. Last name is the number of terms. So if it's just one term, that's called a monomial. Two terms is a binomial. Three terms. Anybody got a guess? Trinomial. Good. Trinomial. Now after that, it probably has a name, but we will just, from 4 on, just call it a polynomial. Polynomial is just the generic term. They're all polynomials, but some of them have like extra special names. If you Googled it, I'm sure you would find some name for a 10-termed figure. 10 terms, but I don't even know those. All right, so let's go and name these polynomials. So first off, let's look at the degree. Now, if you don't see an exponent with an x, you can assume it's a 1. Do you see any larger exponents than 1? No. So that would be linear, because the biggest exponent is 1. And then it has 1, 2 terms. Every time you see a plus or a minus, that separates your terms. So 2 terms would be binomial. So it's a linear binomial. Number 8, what is the largest exponent? 5. Don't add them together. Just, there's really 3 exponents: a 5, a 4, and a 1. The biggest is 5. So it's quintic. So 5 is the largest. And then we have 1, 2, 3 terms. So that would be a trinomial. Now number 9 is just a plain number. There's not an x at all. So that would be a degree of 0. So it is a constant. And it's only one term. Monomial. Number 10, The largest exponent is 3. So that's cubic. And it has 1, 2, 3, 4 terms. We're just going to call that a polynomial. Number 11, the largest exponent is 2. So that makes it quadratic. And it has 1, 2, 3 terms. So trinomial. See if you can get an answer for number 12. So we've got a quartic monomial. And then 13 and 14 is backwards. It's giving you the name, and you need to come up with an example. There are infinite possibilities for right answers. So a cubic binomial. It's got to have at least an x cubed. So let's say we can make it 4x cubed. And because it's a binomial, I need another term. So I need to add or subtract something. So I can add 5x. That would be an example. You could just have x cubed plus 1. But you have to have at least x cubed, and you have to add something. And then a linear monomial, it can only have an x, and it has to be one term. So maybe 2x as your answer. Any questions?